project that we are speaking about today, it took 1 month to develop the model. It was quite an advanced model. You'll see it later. Yeah, so the project was from September 2020 to October 2020. It was a partnership collaboration. So Novo Nordisk heard of this digital twin and really wanted to make an explorative study. So how could they use these digital twins, which added benefits and value did they get for this? And one of the biggest OEMs, machine builder providers for Novo was Stevanato Group. And so we reached out to them and made this planning of how we could make a digital twin that would provide a lot of value to them. And kind of through this whole project, finding the benefits as we go. So it's a very specific benefits that we will highlight here today. From the end user side, some of the customer goals was to, we've heard it a lot during these presentations, but to reduce the time to market, improve the quality OEE, overall equipment efficiency, and then just provide benefit through the whole machine life cycle. So this machine was already made, but they were gonna make multiple of this type of machine. So if we could somehow optimize the operations, and then it provide a lot of value to them. So the phases we went through was a design review, validation, commissioning, virtual training, and then we ended up with a full digital channel. Yeah, so here you see the machine. It's consisting of an Beckhoff XDS system and then a Delta robot. We cannot show the specific products in the machine due to some Novo restrictions. But there's an HMI in which the operator can control the machine. And a lot of pneumatic actuators and a lot of fine mechanical parts. That's really important with this. This product was a very small, narrow, what you call them?
It is an insulin pen.
Yeah, it's an insulin pen, yes. And this machine assembles the pen. Yes?
Yes, so as Anna said, we cannot disclose the product, but I will try to explain you more or less the process of assembling the pen. So the pen gets in feed as you see in that picture. This is just a cut that we made. We see the cartridge, the bottom of the product, and then the dial, which could be the top. So the operator will just infeed the product, and then we'll start the machine. The first module that we have is a vision camera. Actually, it's 2 vision cameras that can move vertically, and then they can adjust it manually. So in this phase, we will just scan to verify the position of all the components for the product. And then once that is verified, we move to the next module, which will be this one. In here, what they are doing is just verifying. So they are verifying that the distance from where we start to when we hit the product is the correct one. And then we move to the Delta robot, which is a Codian. And in here we assemble the icon and the hollow washer and inside the cartridge. Once that is done, then we move to the next module, which will be for pushing down the dose. And then it will spin till we make sure that everything is in the right position, right orientation. And the last module, it could be just putting the dial in the product. As you see, there's a lot of motion and it's a lot of intrinsic parts. And the last part, we go back to the scanner, in which we'll verify different positioning, the scale, the dial. So there's a lot of control on that. So I'm going to explain a little bit how we did it. Prior to start developing, we had a conversation, especially with Stevanato Group, on what would be the main challenges from our side, and as well what was important for them and what was not. And that's where Emule 3D plays a key role, in which we could get the best of both worlds. We could get emulation and simulation in the same model. So we decided, okay, we're gonna do, for emulation, we could use CAD is the model, which is fantastic. We made use of joints, aspects, actuators, motors, the grippers, and then, of course, the load to create the tile. And then, as well, we use the vision camera, and as well, we made a quick draft of a DeviceNet card, which is a barcode scanner that we are lately using more. As well, we modeled all of the Delta robot. We didn't connect it. We made use of the simulation part, which is the robot framework. So we use the robot controller. And for the XTS, as is quite advanced as well, we said, okay, let's use make of vehicle framework, just making tracks, making control points. And then, of course, we will have to adapt a little bit the code to get all of this signaling back and forth from the QI logic to the PLC code. But it was good. And then we decided to go through an OPC UA server, and that the reason is why it's not the best, it's not the ideal situation, of course not. But we are working in a GXP environment, and for them it was really important that we didn't get close to the machine. So, of course, having this possibility of connecting was really nice for us.
Yeah, so just to build on some of the statements that Alvaro made, we work within pharma, and it's a GXP environment, so we didn't get, and it was during COVID in the early stages, so we didn't get a lot of chances to see and touch a physical machine. So having this environment where we could communicate and talk to the stakeholders really provided as a tool for better communication in all partners in this project. This GXP critical environment means that there's a lot of restrictions and regulations towards making any changes in a machine design. So having this digital twin really paved the way to make easy changes, and and also this providing as a tool for better documentation. So what really happened was that Stevento Group would send us all the documentation, design specifications, UIs, you name it, and we would review it. And then having this extra step really helped us in identifying the gaps that was there. So really important in the GXP environment.
Yes.
And then it also provided as a multidisciplinary learning for us. So really finding that
yes,
all these disciplines.
Adding to that better documentation, I would like to play the video as well from this. This is from the Stevanato group site. So it's a quick video.
Imagine if the digital twin was an active part of the design documentation. I have here the design specification for this project, where the digital twin has been made after the design phase. The document is a flat piece of paper with text and illustrations trying to communicate what we intend to build. Imagine if we added the digital twin to this. Imagine if a drawing like this was added a digital twin, and the reader of the design specification could dive into multidimensional details in the digital twin. And what do I mean by multidimensional details? The 3D model from our CAD system could be used as it is already, but it doesn't contain any movements, for instance. It doesn't contain the assembly process, and it certainly doesn't contain the interactions between different modules as an easy thing to understand. All that is included in text and illustrations today, but imagine if we had the digital twin to support the design documentation. I really hope that we can get to the point where the digital twin is creating value all the way from design of the device and the machine to the validation of the equipment as a part of the qualification documentation accepted by authorities.
Yeah. So, as you just heard from our partner from Stevento Group, adding this element of the digital twin provides a lot of value for them as well. So they really opened up to us during this project and was really keen to share their IP and things like this. So So it's a lot of added value to them as well. And then later in the phase where we have the fully operating digital twin, we invited some operators into via headset and provided training with them, with their line staff. So through this, they could in parallel train operators and provide a lot of experience before going out to the actual physical line. And then this digital twin as well provided a lot of user friendliness. Having this environment where you can test easily without all these advanced functionalities on the physical machine really was an easy way to get used to the machine. And then of course during COVID we also found that we reduced traveling a lot by making it from remote. And in these times also reducing CO2 emissions, very important. So I think that's very important to state this added benefit. And for us, this really provided as a good tool for marketing, sales tool. Since this project, we've done many other projects in Novo and other companies as well. So using the digital twin as a sales tool cannot be understated. Yeah, and in addition, once you have developed the digital twin, you get almost benefit from day zero. So that's an important note as well. And throughout the digital twin life cycle, you get the chance to optimize the system, making various what-if scenarios and really experimenting on your system.
Yes. So I would like to add as well to this slide, because we have been speaking from mainly end user, OEM side, and there was a lot of benefit as well from us, ProjectBinder, especially using Emulate 3D. So coming back to the user friendliness, from the point that we started learning to the point that we started developing, it was really quick. As well the possibility of doing all of these customizations, components, that was a really key changer in this project and as well in the projects that came after. Yeah, and this next topic, this is just to give you some ideas and to spark your mind, because, and as well to the Emulate 3D team, because that would be nice to have in the future. But yeah, this is a prototype that we did as well with Novo Nordisk, and the reason of why we are using Apache Kafka is because we wanted to replay past events, and so we can identify what happened at some point in the machine when an error occurred. Why Apache Kafka? It is commonly used in big companies. It's becoming an industry standard. All the data is timestamped. That's the main key. And of course, the high performance, highly scalable, durable, and reliable. So this is the setup that we implemented. Again, it's not the preferred setup, but as well this was a prototype, so it was good enough for us to test and achieve something that was working. As you see, we use the PLC. This is the producer of the data. We were pushing the data to an Apache Kafka cluster, and then as the data, all of the data is timestamped, then with servers running OPC UA and Node.js, we were able to run a script which works like a subscriber, and then after a trigger, in which case we just get a little bit of data, and after 12 p.m. we started pulling the data back to Emulate 3D in the proper way. Yes, and now let's play the video.
Software commissioning is about modularity. It's about keeping the complexity down, limiting the choices in the software to a linear design. And one of the things that we can use the Emulate 3D setup for is to get the mechanical engineers and the software engineers aligned, then they will also have much smoother tasks of integrating it later in the process. What we see often is that the mechanical guys, due to lack of or constraints in time and the deadlines, don't necessarily make the best function specifications for the programmers. And if they can give this 3D model to the programmers, then the programmers will be able to kick off the programming effort much earlier, and we would expect less programming time needed during the project phase. For Novo Nordisk, hardware choices is about scalability. It's about finding the hardware equipment that would limit the variety of components that we need to keep in stock to a minimum. If we have a limited hardware selection, we have modular code to a higher extent than what we've been using in the past, then we will give the programmers more time in his programming phase to think about the non-functional parts of his programming, the GAMP requirements, meaning they will have time to fill in versioning and comments and all the stuff that we need in Novo as part of the programming.
To conclude our digital twin proof of concept, we wanted as a last step to connect the real-time data from the line to the digital twin and create what we can call a digital shadow of the equipment that you can access anytime and anywhere. For example, when you do validation, if you have to do that remotely, or if you do remote maintenance, so you can get access to the whole machine and get a complementary tool to the remote maintenance solutions. For example, in aseptic production, in filling or formulation, we try to get people out of the shop floor. So now we have actually a tool or complementary tool to get the shop floor coming to you. So this could be also quite handy, specifically, as I said, in filling area.
Also, we see this tool being able to help your productivity on the total plant floor. So if you start to connect one machine, then you connect the next machine, and soon you will have the factory as a full digital twin. What we are working with right now is capturing data from the production, from the digital twin, but also from the real line. So what we want to capture is the data and then see if we have a failure. And then we want to rewind that data in the digital twin to see what went wrong. So in that case, we can release the production again very fast, as we can pinpoint the reason why the machine failed or why this product did not work as intended.
It has been quite an interesting journey, this proof of concept. We have been positively surprised. We can definitely see a huge potential for the years to come.
Basically, we have achieved learnings by the investments made. We have become more specific in what we want to achieve in the next steps. We have realized that our customers expect this from us already, and we are on the digital train running at full speed now.
We know that the journey has started for a lot of people, a lot of companies. If you want to be more productive, you want to have your time to market as one of your business drivers, you need to jump on this train now.
Yeah, I don't think we're showing this video. Okay, sorry. Yeah, so I think that was it from our side. We had a great success in developing this digital twin with our partners, and we would like to welcome any questions you might have.